Good morning, friends. I have seen many superheroes who can walk through walls, but when I tried, I had a huge band aid on my head. Is it true that no particle can pass through wall? Interestingly, very tiny quantum particles do pass through wall by a phenomenon called as quantum tunneling. How is it possible? Let us explore the science behind it today. Every particle is associated with a wave character given by the equation lambda equals h by p and lambda equals h by mv, where lambda is the de Broglie wavelength, m is the mass, and v is the velocity. For example, a phone, which is a particle, has a wave character and can be present at different points at the same time. It is just like the water wave, which is present at many places at the same time. But as the phone is big and has high mass, the wave character is low according to the equation. Very tiny particles have less mass and high wave character. They can be present at different points at the same time. Let us do an experiment with laser and CD to prove that waves can be present at different points at the same time. So, the secret of tiny particles to pass through wall is being present at different places at the same time. Let us see how tiny particles pass through wall. A tiny probability of the wave is present on the other side of the wall. This is how quantum tunneling happens. Do you know that the sun shines due to quantum tunneling? We know that nuclear fusion of proton happens in sun. Fusion happens when protons combine, but basically like charges repel each other. As the protons have wave-like character, the protons tunnel through the barrier and some probability do come into contact and fuse, making the sun shine and aiding life on Earth. Quantum tunneling has important applications to modern devices such as tunnel diode, scanning tunneling microscope, and many transistors. Thank you, quantum tunneling, for making the sun shine and powering our modern gadgets.